Hi,
Hi, good morning.
good morning.
How are you?
Good, how are you? I just saw
I'm
your
doing
email
good.
now.
Yeah, no worries. I just sent a document in case I'm not able to put it in chat. Um,
I'll make you
I'm
a
assuming,
co-host so you can share your screen.
yeah, that would be awesome. I have a Slido, so please make sure to open that up. And I'm hoping that you guys are able to see my screen. So today we're going to be talking about space education in classroom. I have a background in astronomy and planetary science, and this is very, very near and dear to my heart, bringing space to students across Canada. And one of the neat things about space, as you will see, is it's very interdisciplinary. So to start off, my question for you is, what comes to your mind when I say space? So how about you guys kind of open a tab, or if you have a cell phone, go to the Slido website and enter this particular number. So it's hashtag 13187. And I would love to see what you guys have to say. And so to do that, I will actually switch my screen so that you guys can also see what others are saying. And so this is what it looks like. Again, the number is, and it's strange that I actually cannot see the chat. So give me 1 second while I figure that out. Exploration, yeah, that's perfect. So I'm actually going to keep moving my chat here so I can see if anyone has any questions in the chat during my talk. Mars lower writing today. Yes, Perseverance. Percy is landing today, and I will talk a tad bit about it today. Planets, NASA, astronauts, vacuum, mystery, planetary science. Wow, it looks like astronauts, planets, massive. I'm assuming someone probably said massive stars or massive planets. But yeah, you guys can see there's such a great variety. Universe exploration. Carl Sagan, yes, one of my great inspirations. Big Bang, planetary bodies, curiosity, rockets, Apollo, survival. Wow, you guys have already been thinking about this. This is really exciting. And I'm seeing some new ones pop up. Craters, yes, I love to talk about craters. SpaceX, sci-fi, stars. I mean, I'm hoping some of you watch Star Trek or Star Wars. I'm a Star Trek person. But yeah, great to see Chris Hadfield. Yeah, great to see that you guys are, already into space and are aware of so many different things that happen in space. It's not just, sending rockets or sending humans. There's such a variety of things that happen in space, and I'll let it keep going for 30 more seconds. Guardians of the Galaxy. Yeah, I'm excited to see such a variety of answers in there. Awesome. So it looks like it's kind of paused. So let's go back and kind of go through different aspects of space. So when I talk about space, most of the time people think about astronauts, people think about rockets, maybe planets. But it's interesting to see that space is such a diverse field. And this is one of the things that I particularly like. I can be in engineering, medicine, technology, food science, geology, astronomy, physics, health, law, policy, chemistry, mathematics, business, geography, education. All of this you can connect to space, and there's so many more, communications and a wide variety of things. Artists, everyone come together to talk about space, work in this particular industry, research, academia. There's so many ways to be involved in space. Given the amazing interdisciplinary nature of space, it brings so many people together to work on particular tasks or questions that are unanswered. A good example of this is astronauts. A lot of the times when we have astronauts in space, people think, they are the only people who are working on it. It's actually hundreds of people here on Earth who are involved in that mission, whether it's planning, making sure that they have food, making sure that, their schedules are aligned, they have a lot of experiments to do while they're on the International Space Station. There's such a wide variety of people that work in this field. So I'm going to highlight a few of these, and feel free to ask me any questions you may have for any of these, topics that you may want to discuss in Q&A. So to start off, I'm going to start with history, a tad bit of history. And there is a reason why I'm starting off with history. Some of you may know Dr. John Chapman. He was born in London, Ontario, and he's known as the father of the Canadian space program. And interestingly, he also has a bachelor's from University of Western Ontario. So, go Mustangs. But the reason why he is known as the father of the Canadian space program is because he was instrumental in actually launching the first Canadian satellites that was built right here in Canada. And it was launched in 1970s. And the reason why, 1965. The reason why it's very important is because this actually allowed Canada to be the third country in the world to build their own satellite and actually to, launch it using our lovely collaborators down in NASA. And so he was actually instrumental in coming up with a project, launching this particular satellite. And then he also wrote this amazing report that suggested that we should be forming a space agency, which happened pretty later after the report was written. But he was kind of that person who said, we really need to form this agency and bring in our efforts to work towards being part of space exploration. And so I really wanted to hint at that because some of you may want to start, when you start teaching space, you may want to start with a tad bit of history and the fact that you are doing your BEd at Western, there is a Western connection to the whole start of the space program in Canada. And so now, between now and kind of, until the end of this 40 minutes, what I'm going to do is I'm going to get through different topics that I think would be useful for you guys to bring into classrooms, along with a few resources for each of these topics. I have a PDF that will be sent to you that also links all of these different resources that I'll be talking about. So don't worry about having to, note down where these can be found. So to start off, I'll start off kind of from here, right on Earth, in terms of, using satellites in our daily lives. And a lot of people don't realize how much we use satellites. One of the most common ones that people know about is GPS. We use GPS all the time that connect to the satellites that give us the most updated information. However, there's so many other uses of satellites that we generally don't think about right away when we ask someone, what do you think satellites are used for? And so I'm going to highlight a few of them. There are obviously wide variety that you can find a lot more details on our website. But the first one is climate change. Here in this picture, what you are seeing is actually an image of one of the volcanoes erupting. And so this is very important for us as humans to be looking into, how satellites can help us gauge what is happening to our climate. How is that changing over time? We can actually take pictures before and after to see the effect of so many different factors that affect climate change. In addition, we have agriculture. A lot of people don't realize that farmers actually use data from these satellites to look at the soil moisture. They look at, obviously the rainfall. There's the weather pattern that is very important for them in terms of, making sure that the crops are going to be healthy. We have the ecosystem. Canadian satellites actually monitor the entire country to look at different ecosystems. This could be looking at wildfires. This could be looking at deforestation, our lakes, our Canadian waters. Looking at how that is changing and keeping tab on all of the things that are happening across the country, and making sure that we are able to take steps to mitigate those based on the information that we're receiving from these satellites. We also have the Great Canadian North. We obviously have a lot of ice around our northern provinces and territories. And what is really critical is that if marine ships and people are exploring these areas, we would want to know what's the ice coverage, how thick it is, to ensure that people are safe when they're exploring these areas. So we use a lot of satellites to be able to do that as well. In the past, and as well, very much right now as well, we're using satellites to actually make sure that people are safe. And a good example of this is, flooding in Louisiana during the hurricane seasons. They actually monitor, the water levels, where are the most water levels and where to send the disaster and rescue crews to make sure that, they're able to save people from any kind of danger. We are also able to look at the health of for humans to be healthy as well. And then last but not the least that I'm going to touch on is Canadian waters. Like I mentioned, for the Great Canadian North, but also down here, our lakes, our rivers, all of those are monitored using satellites on a daily basis to ensure that, it's safe to be out there on whether it's a lake or any kind of, inlets or rivers that people can actually explore. So these are just a very thin sliver of potential ways we can use satellites in our daily life. I'm going to jump into another project that is related to satellites, but in a very different way. This is Cubesat. And so Cubesat project is where you have a small 10 by 10 by 10 centimeter sized cube that various universities across Canada have been funded to actually develop and launch these. And what is really interesting is that our collaborator, the European Space Agency, actually has a very neat activity that you can use in your classroom. It's called CANSEC and CADSAT. CADSAT is something that you can do at home or give your students to do. And if you just go to their website, they allow you, or the students, the high school students, to actually put themselves into teams and develop a small CubeSat or a CAN-sized sat to send up into space. And it's a competition that's currently going on. And we hope that it will come back in fall if you plan to use this as a resource in your classroom. Another really cool one is Exploring Earth project, which is also related to the satellites. Here I have an image of the RadarSat constellation. These are 3 identical satellites that orbit Earth and take amazing high resolution pictures of Canada. And they give us a very much up-to-date information on all the aspects that I mentioned before. And so there is a really neat activity called Exploring Earth that you can find on our website. There are amazing pictures taken by satellites, but also by astronauts of different phenomena that are going across the world, different kinds of landscapes, features, as well as different kind of climate activities that are going on. So you can find things like, volcano that is erupting, but also at the same time, images of like wildfires and even things like, ecosystem as well. So that's another really cool activity that you can check out, and there are curriculum links as well. So you don't have to worry about having to match that. That's also available on the website. Another neat activity that was developed using the RadarSat images was this giant floor map. Some of you may be aware that the Royal Canadian Geographical Society has this giant floor map that you can actually request for free of charge for your classroom. And you can have it for 3 weeks, and it's pretty big, so you will definitely need a gym to be using it. But this is a picture of Canadian astronaut David Saint-Jacques. He had this particular map up in the Arctic when he went. And this is pretty unique because in 2016, the map was actually developed to have activities with it, particularly for the people in the northern communities up in the Arctic. And so you can find these activities actually come with the map, so you don't have to worry about developing any kinds of activities. And you can go to the website and request it for free. What's really neat about this, and I've actually seen this particular activity in person, and what's really neat is that it gets kids to actually work in groups and explore different parts of Canada, as well as learn about how mapping actually works. So it's not just about learning about satellites, but it can include things like geography, as well as things like, how do you actually map something on Earth using satellites. So it's pretty neat. And please feel free to check it out. It's free of charge for you to actually order and have it. I will also mention that they do also supply the map during the summertime, but that's in a very limited number. So in case you are planning to use it for other reasons during the summer, it's a possibility. It's just a little bit harder because a lot of people ask for this particular map. So now kind of moving a little bit away from Earth, let's talk about our International Space Station that Canada is part of. And it's an amazing laboratory that orbits Earth at around 400 kilometers from the surface. And we have had a continuous presence for more than 20 years on the International Space Station. And many Canadian astronauts have been part of the missions as well. And what's really interesting is that even though it's only 400 kilometers away from the surface, it allows us to do a lot of science and test a lot of technologies that we otherwise would not be able to do. And so one of the things that Canada has been working and has been pretty, I would say expert at is a couple of different things. The first one is robotics, and I'll talk about the Canadarm in a bit. But it's also in terms of looking at health. So we have, whenever we send astronauts, we have a huge team of, experts in medicine, health, kinesiology, as well as food that, work with the astronauts while they're on the mission. And here is an example, Canadian astronaut Robert Thirsk. He is, exercising in space. As you know, health is pretty important, not only here on Earth, but also in space, as you're not in a gravity-bound environment. So, your body starts to react very differently. And experts actually study this particular, how is body affected when we're in space? Especially if you're counting, if you're planning to go to Mars and beyond, you're now starting to think of going to places where you may not have access to a doctor pretty quickly, or even to the International Space Station. And astronauts do have to learn how to do simple procedures and to make sure that, by the time that they're brought back to Earth, they're able to actually, make sure that they're healthy during that time. And so there's a lot of research that goes on for that. But one of the things that's pretty interesting and a lot of students ask about as well is, what about food in space? How do we eat? And so what's really neat is that scientists have started to experiment with, growing food in space. How is it different? And as you see down here in the picture, Canadian astronaut David St-Jacques, who was on the space station a couple of years ago, he is looking at a lettuce that is growing on the space station. And so it is a neat activity where you can actually get students to think about what are the differences between here on Earth and on the International Space Station. Obviously, there's gravity that's missing. And so there is a neat project by Let's Talk Science that is the tomato sphere that you can actually order seeds that you can grow in your classroom. There are 2 sets of seeds that you get when you do order. Again, it's free for you to order them. One is either exposed to a space or space-like environment, while the other one is just a test comparison to make sure that, if there's something that's growing on Earth versus something that's growing on in space or space-like environment that has been exposed to. And so that's another neat resource that you can use. It's free of charge for you to apply. You will get seeds to use in your classroom, and you will be able to see how these tomato seeds actually grow that have been exposed to space. Another really neat activity that's available on our website is called Space Gardening or Space Gardener. This is where you compare the plant root growth between the ones that have a nutrient-rich soil versus a normal soil. And it may sound like, well, you could do that here on Earth, like how does it have anything to do with space? You can think about when we're planning to go to Mars or Moon, in those circumstances, we would have to think about how we're going to grow these plants. What are we going to do with them? Are we going to be able to use the soil that is available there? Maybe it doesn't have things that we need. So, you know, thinking about it from that perspective of it being nutrient rich or not. Thank you for someone who posted the link. So onto our robotics expertise. So Canada, as you may know, on your $5 bill, we have the Canada arm, and we are known around the world for our robotics expertise. And so in this picture, you can see we have the Canada arm that is on the International Space Station. It basically is almost like a grabber. It grabs onto satellites, but you can also service the entire space station using this particular robot. And so that has been, you know, going around for a while. And you may know that a lot of astronauts actually use this to go around the International Space Station and service it. So just to give you guys an example, here is an image of a Canadian astronaut, Jenny Sidey-Gibbons. She is being prepared to practice how it's going to feel like to be in space and how to work using those different tools that they'll be using. But you can see that here on Earth, like she's being fitted into a suit. And it doesn't look very comfortable. It's not like how we put on our garden gloves and start working on things, right? And it's interesting to see what astronauts actually have to do when they go up there. You know, they have to put things together. Sometimes they have to repair the telescopes. Sometimes they have to repair different panels or clean things on the International Space Station on the outer side. And as easy as it looks, or as easy as it may look like, it's not actually very easy. And there's a very interesting activity on our website that you can find. It's called Moving and Working in Space. It actually simulates that particular experience of how hard is it to work using, you know, gloves that are way bigger than what you would think. You know, it's not something that you would wear every day. How are you able to hold things? How are you able to manipulate things based on, you know, wearing such heavy gear? So it's a really interesting activity. I personally use that with very many set of students, and they absolutely love that particular activity because there is an element of competition in that activity as well. So I would invite you to check that particular activity out as well. Another really neat initiative, now we're going a little bit further. We talked about Earth, we talked about International Space Station. I'm going to talk about going a little bit further to the moon. And so to start off, you may have heard, we have a junior astronaut campaign that is currently going on. In this particular campaign, you know, it was made to ensure that students understand what it takes to be an astronaut, but also be exposed to different careers that are part of being an astronaut, or the people that you would encounter during your journey of being an astronaut. So currently, the students are actually, until the end of next week, are still able to register. And for you as an educator, there are a few things that might be really interesting for you. The activities for the junior astronauts were divided into three different, I would say, you know, types, or three different key areas. One of them was science and technology. You know, all scientists or whoever goes to the International Space Station will have to do some science and test different technologies, so they need to have a tad bit of understanding. So there's a whole slew of activities that are for science and technology theme. All the astronauts who do go to the space, they all have to be pretty fit. They have to ensure that, you know, they're healthy, they're making sure they're eating right. So there's a whole set of activities based on fitness and nutrition that is something that you can also use in classroom. And then last but not the least, and actually one of my favorites, is teamwork and communications. International Space Station is an international collaborative effort, and so will a lot of the future projects will be. And so it is very critical for astronauts to be working with people from other, other places across the world. And so teamwork is very important. They're never going to be alone. They're always going to be in teams of 2 and 3, or sometimes 6 or 7. And they have to effectively communicate with someone else who may not speak the same language, or maybe bilingual or multilingual in many cases. And so these set of activities are great to start off your unit as something, in terms of team building, if you want to use it, but also they're all space related as well. So, you're kind of doing both at the same time. And just to give you a quick overview, these are some of the activities that you can see. We have the space repair for fitness. There are some activities that require them to be active physically, but then there are other activities in, the green ones are the ones for teamwork and communications. And as you see, there are things like Dragon's Den, you have to try out your idea, but also things like deep space diplomacy. So there's a whole range, and each of them are, given by their difficulty level, their duration, and what kind of material you're going to need. And so, based on all these activities, you can figure it out. And by the way, these are all available on the website without actually even signing in now. So you can access them anytime. And just to give you guys a quick kind of, I guess, a snapshot of these activities that have been done before. They are very hands-on. So if you're looking for something that are hands-on and engaging and requires a lot of teamwork, these are some of the pictures from some of the workshops that have been conducted for junior astronauts in the past. Now, when Junior Astronauts was launched, we did have a really neat campaign going on for educators. If any educator did this in their classroom, they would be entered in a draw, and they would win a visit from an astronaut. Obviously, because of the COVID situation, they're currently happening. Winners have been selected already, and they're currently happening. And a lot of educators from across Canada are actually getting visits from astronauts virtually because of COVID. But you can still access the resources and activities. And if you have any keeners, the camp for students is actually happening this summer, and the registrations are still open to put their name in the draw until next weekend. So if you know any keeners, please do feel free to pass on a junior astronaut activity. I should mention that the activities are geared towards grade 6 to 9. However, you can always, depending on the classes you are teaching, you could possibly use it for younger or older age groups as well. All right, so kind of still talking about the moon, some of you may have heard that NASA is leading the Lunar Gateway project and Artemis program under the Artemis program. In this particular program, NASA is working with different agencies across the world, including the Canadian Space Agency, to develop a space station around the moon. So we have one right here, but having one at the moon will give us much more information on how it would be as we plan to go to Mars. So, this is kind of our first step in our destination to Mars. And we Canadians are actually going to be providing a few different things in the mission. But what's really neat is that this is not something that is far off. As you may think, a lot of the times, all of these missions take a while to get going. Artemis is actually going to happen very soon in 2023. Gateway is going to be it's going to start being built in 2023, and it will be built in different stages. So just like how the International Space Station was built, there'll be some modules that will be sent, and then over time it will be a complete space station within 3 years. What's interesting is that under the Artemis program, in addition to the Lunar Gateway, there's going to be the main drive is to get humans back on the moon. And so the first set of Artemis mission will be launched in 2023. In this first mission, they'll be going around the moon and coming back to Earth. And the mission is going to be around 10 days. And it was announced in December that we as Canadians will be part of that mission, and a Canadian astronaut will be one of the astronauts who will be part of the Artemis mission. So, Canada is going to the moon, and we're really excited about that. And so do keep an eye out for those. And you know, as I said before, we are an expert in robotics, and so for the Lunar Gateway, we're going to be supplying a Canadarm3. So it's going to be similar to Canadarm2, but obviously it's going to be working, autonomously, because of the fact that if it's orbiting a moon, there are going to be times where we will not have communications with the gateway, and it will have to figure things out itself. So it will be an AI-enabled robot that is going to be making sure the station is working fine, it's being serviced as it should be. So please feel free to ask me any questions as you may have for these. But what's really interesting is that as we look forward to these upcoming missions, we're actually currently working on these amazing resources for educators. So this project, this initiative is called Objective Moon, and in the month of March, we're going to be, releasing the website. So just stay tuned. We'll have lots of information for you guys, including a moon teaching toolkit, and this toolkit will have all moon themed resources that you can use in classroom, again, for free of charge. It will also include a lot of indigenous stories of the moon as well. So there is a whole breadth of a lot of different initiatives that are coming up in next few years related to the moon as we do prepare to go to the moon. So just stay tuned, and I will make sure to give you guys link to the mailing list. So if you guys are interested, wanting to know about when all of these resources come out, and just sign up for the mailing list, and you will receive information as things are being updated on the website. Okay. Thank you, Emily, for adding that link. To kind of go further out from the moon, let's talk a tad bit about Mars. And as you may know, today Perseverance is attempting to land on Mars. 2 missions, one from UAE and one from China, have already reached Mars this month, and now it's NASA's turn. And this is an artist's conception of Perseverance on Mars. It is going to be landing in a crater. So someone mentioned crater in our, what are the things you can think of when I say space. It is landing in a crater that has a riverbed or a delta. And so it's a perfect place to look for any kind of fossilized life that may have existed on Mars. And as you may know, that we have had Spirit, Opportunity, Curiosity, all kind of helping us to get to that particular answer, whether there was life on Mars. What's really interesting about this, there are actually a few different things that are interesting about this, this mission. First is that it is not only looking for life, it's also looking for things on how humans, when they do get to Mars, how are they going to utilize different things. So for example, MOXIE, one of the instruments, is going to try and produce oxygen from the carbon dioxide rich atmosphere that Mars has. Another neat thing that Perseverance has is it's carrying a tiny helicopter with it called Ingenuity, and it is going to attempt flying on Mars all by itself. And so that is going to be a very neat thing that is going to happen. So today at 4 p.m., you should tune into the NASA Live event and see if the landing happens. And feel free to ask me any questions you may have. Yeah, I should mention that the PDF that I will be sending you all does have all the links that you require for everything I'm talking about today, everything from all the junior astronaut resources to the floor map to the exploring Earth. So don't worry about the links. I will be sending them. Going further than Mars, I should also mention for Mars, there is a Canadian, CSA is actually funding a Canadian scientist to be part of the team. So when this particular mission actually decides to, bring back the rocks. So the idea for this mission is that they will collect a few rocks, they'll be put in a box. Future missions will be going back and collecting those rocks. When we do actually get those rocks back, some Canadians would actually have access to that. So that's a pretty neat Canadian perspective for the mission. All right, so to kind of go a little bit further, here is asteroid Bennu. Canadians were involved in a mission called OSIRISRex, and they're actually also actively involved in this. And this particular asteroid is a near-Earth asteroid, so it's very close to Earth, and we kind of wanted to know what it's made of and learn all about the formation of these rocks, asteroids, but also at the same time understanding the formation of the solar system as well. And so Canadians contributed what we call OLA, or the OSIRISRex laser altimeter. So it's basically shooting lasers at this lovely rock and learning about what it looks like, you know, creating a 3D map of the asteroid to actually then go and pick up samples and bring them back to Earth. So in late 2020, they were able to pick up samples. The bottom picture on the right-hand side is what you're seeing is actually a picture from the OSIRISRex that was taken as it was grabbing material from the surface of the asteroid. And then in 2023, all of this is going to come back to Earth, and then Canadian scientists will actually have access to that material to understand what this particular asteroid is made of. Obviously, we learn a lot from the satellites, but it's very different, you know, if you're a scientist, to actually be able to hold your samples and you know, work with it. So we're looking forward to that. There are a bunch of activities related to asteroids, as well as a digital game that's available on our website for OSIRISRex, and the link is also included in that PDF. And then last but not the least, as I kind of wrap up the presentation, I also wanted to mention something that's coming up. So in addition to our Objective Moon or moon-themed activities that are coming up in the next few months, later in the year, you're also going to see a lot of buzz about the James Webb Space Telescope. So this is going to be the newest, best telescope that we're going to have to look at the universe in an infrared range. And what's really interesting is that Canadians have actually contributed not one, but two instruments. There is the near infrared imager, which is also a spectrograph, and fine guidance sensor. So it will tell the telescope when to move when you're looking at different objects in the night sky. And so for this particular contribution, we are going to actually be able to get time on the telescope. I mean, by me, I mean, you know, different scientists across Canada will be able to apply for time on the telescope. And so we are coming up with different activities that are based on the James Webb Telescope that will be on our website as well for the James Webb Telescope. And if you are going to sign up on the mailing list, you will also receive kind of the links to those. So, you know, as I kind of went from Earth to further and further away, this is kind of what we are looking at the universe. There are many more, you know, missions that we're a part of, but haven't been able to touch all of them just because I wanted to bring you guys the resources that are available. And then to kind of cap off, I wanted to show you guys a couple of different posters that I think might be very useful for your classrooms. One of this is for a younger age group, while the other one is for a little bit older age group. It kind of gives you an idea of what scientists do when it comes to space. So this is one of the two posters that are available. I mean, in addition to many posters and videos and podcasts and things that are available on our website. This in particular shows the different kinds of possible careers you could have in space. Like I said before, a lot of people don't think about you know, someone in business to be related to space. You know, you could be an entrepreneur nowadays. You could be in education field and still be related to space. You could be a psychologist, a doctor, or like a mathematician. Those are all something people don't think about often. So, you know, if you're teaching a younger age group, feel free to use this. If you're teaching an older age group, you know, here is another one. This is actually taken from one of the analog simulations that we did. Both Western and the Canadian Space Agency were part of that simulation. And here are some of the actual people, and I actually know 3 out of 5 people on this image are Western University students, and they were studying different things. You have geologists, you have, you know, geophysicists, you have robotics engineers, you have space engineering experts, all of them coming together to try and create what it would be like to be on Mars or on Moon, to have this particular rover work there. And so, again, another way of kind of linking different careers to space. You could be in very many different careers. And so in addition to videos, posters, and podcasts, some of the things that are not very well known in terms of things that you can get from the Canadian Space Agency, in addition to the activities, is you can actually request a speaker for free of charge. You can either request any of the astronauts or any of our experts to come into your classroom and talk about, whatever topic you are talking about. An example I would give is, if you're talking about Earth observation, or if you're talking about satellites, mapping things, we have experts in those areas and they can come to your classroom. So if you go to our website, you will see that there is a request a speaker tab. You can click on it and submit your request. If any of the experts or the astronauts are available, you will be able to schedule virtual. Before, we used to do in-person visit. We don't know when that's going to happen, but you can still actually do virtual visits right now and request for those as well. And then, feel free to sign up for the mailing list if you want to keep receiving the updated information on any of the new resources that we have. And so I was just 2 minutes over, but I will stop here. Feel free to follow us on all social media to just, keep yourself updated. We do also post about resources on social media as well for educators. So I hope that was useful, and I'm happy to take any questions that you may have. Yeah, please feel free to either put your questions and or any of the, I hope it was useful. We went through a lot of different resources. I totally understand if it takes, so the Instagram handle is Canadian Space Agency, and the Twitter handle is CSA_ASC for English. We have both English and French, so feel free to follow whichever you feel comfortable. Any questions? How far advanced would you need to book a speaker? I would say at least 2 months in advance. So, 2 months is kind of minimum if you are planning, to teach space unit in a certain time frame. Let's say you're starting to plan everything and you plan to teach it in October or November. Make sure to try to get in as early as possible, but at least give minimum 2 months for them to schedule. And obviously, depending on the schedules of the experts and astronauts, it may vary. So, do give a whole bunch of different dates or a particular range of dates for them. It will make it more easier for us to kind of book a speaker. Any other questions? Where can we get the PDF? Okay, I'm gonna try and see if I can, so I'm actually unable to add a document to this. And I'm just wondering if Kate or anyone else.
Yeah, sorry. So the people who are running this week, they did contact Katie Mennonite, with the teacher education office. Mm-hmm. So they're going to post it on the teacher candidate website. But I think I could also, if I see enough people's names in this chat, I'm pretty sure I could also just email you as well. If you personal message me your email, if that's easier for you.
Yeah, and I will see if I can, I'm trying to see if there is a way for me to make the PDF publicly available or anything like that. I would say let me actually first post the one that is where you would find all the activities, in that way, at least you have a thing to get started with. So feel free to add, questions that you have, and I'll just find that PDF and try and add all the links here, which is not very convenient, but that's okay. At least you guys can, start with bookmarking those links. Yes, I agree. Zoo Universe is an amazing place for citizen science projects. I would also say that, you know, a lot of our collaborators like the European Space Agency and NASA also have a lot of resources. I would say one thing that I did mention, the European Space Agency's CANSEC and CADSAT. We as Canada are a lot of the times eligible for a lot of the competition and challenges that European Space Agency has, and that's because we are a member state. We're one of the 2 non-European member states that can actually be part of these things. So you, as an educator, can also apply to their educator conferences or any kinds of bursaries or things like that for your classrooms as well. So do check out, you know, all of their challenges and just make sure to read the guidelines, because a lot of the times they will say at the bottom that, you know, these are the following countries that are eligible, all EU members, and as well as Canada and a couple of other places around the world are also eligible. So just something to check. Okay, I have a couple of questions here. For Junior Astronaut program, can you do it in your classroom, or is it a program that students go to? So you can actually do these activities in your classroom. All the activities there are listed on the Junior Astronauts. Let me actually post a link to that. You can right now even get those activities without logging in. You can download them, and I'm going to send the link to everyone so that everyone has access to that. And you can do it with them. You can also assign those activities as something that students can go and do as well. So currently we have opened it up for everyone, and anyone, you know, even if there are people who are homeschooling their kids, they can actually have access to these activities and do them in class, during their education as well. So feel free to just go under streams and activities and, you know, sift through any of the activities that you may like to use in your classroom. They come in 2 different ways. You can download a PDF or just, you know, use the website to go through the entire thing. So yeah, thank you for that question. What is an ideal classroom environment to facilitate space learning? I think just because space is such an interdisciplinary, but also at the same time requires everyone to work together, I feel like any kinds of projects that allows them to, you know, work in different teams, also at the same time, allows them to communicate those things, whether it's through different activities or within that project that you have assigned. I think that particular setting is very important, because if they were to go into any kind of space related field, they'll see that you are going to be working with very many different people from across the board. So I would say any activities that engage them in teamwork and communications are critical to their development. And obviously there's always a space spin to everything, but that is something that I feel creates a great environment for them to learn from each other as well if you provide different projects to them. So I hope that was helpful. How do we add international component to our curriculum through space education resources? Yeah, that's a very good question. I know that grade 6, grade 9 curriculum for astronomy, earth and space science are very much Canadian, and which is great. You know, we're doing so many things. You can always bring in that particular international collaborative effort. Obviously, things that you will find on ESA and NASA websites are linked to their curriculum and not necessarily ours. So I found, and this is something that I've done in the past with various classrooms, is a lot of the times educators have this project that students have to work. And during those projects, you pick different topics that would help them kind of look at things beyond just you know, Canada or what Canadians have done. One of the other things that I've found really interesting, it's actually a set of teachers here in London who have developed an entire grade 9 science curriculum to be themed around Mars. So a trip to Mars, you know, they're thinking all about what it's going to take to be there. They're going to look at the chemistry, the biology, the physics, and all aspects of it. So that's another way. Obviously, that's a much extensive way, because now you are thinking about all of these different research that have been done beyond, CSA or Canadians, and you're incorporating all of those together. But I would say it's not easy, but I would say, if you have different projects that you do plan to give to students, it's one of the most easiest way to kind of branch out into a lot more topics that are still very Canadian, but can involve a lot of research and things that other agencies and researchers are doing outside Canada. Thank you. I'm glad to hear that you find it useful. Yeah, definitely. Tomato-Sphere is an amazing program. There's so many things you can talk about, everything from biology to physics about things. So yeah, I'm glad you'll be using, and there are many more. I will also, while I talk, kind of add more links to the chat for the resources that we have as well. And please do feel free to ask me any questions for any of the Canadian resources or otherwise as well. And if I put on my Western hat, there is also the Institute for Earth and Space Exploration that has some of the resources as well. It looks like I pasted the same thing. Apologies for that. But the last link, or the last two links, are for the Exploring the Earth project, which I mentioned. This is another project that is pretty neat, where you are actually able to go and look at different pictures that were taken over time. There is the giant floor map. And this is the moving and working in space, one of my favorite activities that I've done with kids. It gets them really excited and also competitive. Here are the OSIRISRex activities. So apologies for putting it like that. Hopefully you guys will get a PDF at the end that does note all of these as well. One of the other ones I would also like to mention is that the CANSEC design challenge that I mentioned by ESA, there is a Canadian group that is leading the Canada side of things. And so here is their website. You will see that they do have challenge for secondary students. And so, I think they have already selected their teams for 2020, 2021, but they will be coming out with new theme for the fall. So, this is something if you're planning to engage the kids in some kind of building aspect, then this is a great activity to kind of, look into. Feel free to contact them. The organizers are pretty open to kind of talk to educators and involve the students in the challenge as well. Here is the CANSEC one. Yeah, please feel free to ask me any questions you may have. The last one is the CANSEC link. Okay. And I think here is the mailing list website. So this is where you can sign up for the mailing list if you guys are interested and wanting to get notified when we do upload the objective moon resources in the next couple of months. Yeah, we're looking forward to those initiatives. A lot of them are targeted to high school students, and so a lot of you might be interested in those resources and getting them engaged in those activities as well. Yeah, those are the links I have. The rest of the links are basically basically information that's available on our website. Which of these resources would you say would be best for younger students? And there are a lot of activities for younger students in the junior astronauts, as well as I would say, some of the activities that you will find in OSIRISRex activities list I think that is something that I already sent, but just not, if not, here it is. You will find a lot of these are very much geared towards younger kids. Here's a cool activity. Some of them are collecting asteroid samples, and this you can mix it with grade 4 meteorites, but also grade 6 Earth and Space Science, as well as making your own asteroid. So what kind of components go into making an asteroid, and kind of comparing it to what we find here on Earth. So those are some of the OSIRISRex. Junior Astronaut has some of the activities that would be easily done with younger age group, as well as you could still do Tomato Sphere and the giant floor map with the younger age group as well. They both come with different set of things you could do for the younger age group. The Exploring the Earth one, I think that one would be grade 6 and above, just because of the fact that they kind of have to look at different aspects of what you're looking on Earth, and kind of using that to understand different phenomena and features and things like that. CANSEC is obviously also something that is high school. So anything other than those kind of the two I mentioned would be easily done with younger students as well. One of my, I think, favorite activities from Junior Astronaut that is applicable to any age group is part of the teamwork and communications. That one is called, I think it's called make me a patch make. Patch? Oh God, it's a tongue twister. Basically, it's making patches, but it is such a great teamwork activity because you're not only having them think about the mission that they want to go on and what it would represent, but then also at the same time, you're going to have them start thinking about what it means to work with other people and create a patch. So it's again, at any age group. I've done them with grade 4s, but I've also done them with like grade 9s. So yeah. Awesome. I hope this was useful. Feel free to get in touch with me if you guys like. I'm available on social media if you guys have any questions. We'll hopefully get this PDF to you guys as well, so you guys don't have to keep saving those links that I just sent you. But if you have any questions, feel free to send that to me personally or to CSA with any of the social media tags. Thank you. My social media handle is my first name, last name, Parshati Patel. You can find me on Instagram or Twitter.
So I think that's all the questions. So thank you so much again for coming to leading the session for us. And for everyone else in the chat, make sure to fill out the check for understanding on the teacher candidate website so you get credit for this.
Yes. Thank you. Thank you for having me.
Okay. Okay, I will.